going elsewhere because the space is extremely big. So in the occasional time in which that, some of this ejection of the particles and the mass coming out from the sun would be able to hit the Earth's ionosphere, no doubt about it, most of our effects will be interrupted. I mean, there were, for example, in 1989, there was this major event of the sun's spewing out a whole bunch of this gas that actually was able to actually fry some of the transformer, the electrical transformer in places like Montreal, that where, you have blackout for hours, you things like that, event like that. So there is no doubt that there is such a strong essential control of the sun's, whatever it does, it's going to be very, very important, and therefore we should do quite a lot more, in my sense, to try to study a lot more about what the sun can do. Therefore, we will gain a sense of preparedness in the sense of how to anticipate some of this potential disruption in terms of social life, how we function actually on planet Earth.
I understand that the grid, when people refer to the grid, they're talking about the energy grid. Is that what they're talking about?
Correct. Electrical grid, right?
Yes.
I mean, it's basically built it in the sense that so that, in one part of it got shut down, you can close off the other so that you can still function. This is why this sort of system is built by electrical engineers long ago, to make sure that you have a somewhat, safety-proof system where one part break down, you will not affect others. But sometimes now we are so interconnected and we don't have a lot of this extra preparedness that we're going to cost us a lot more if we don't get prepared on it, rather than wasting time worried about CO2, for example.
What would you recommend, you and David, in terms of getting prepared for sudden changes? And do you sense there may be sudden changes or changes that are difficult for us? I
have been advocating, for example, more diligent monitoring of the sun itself. I've been advocating a lot more public education, of course. And then, for example, if there were to be complaint about, if we have one of these transformer fry and we don't have enough supply of it, I say go ahead, hurry up, and then prepare and invest more in terms of extra transformer.
What does a transformer do? Fill us all in.
Well, it's essentially to try to be able to... Well, Dave, maybe you speak on this, Dave.
I'm not an electrician, but my understanding of an electrical transformer is that essentially it steps down power from the electricity that's being transmitted in the electrical current in the wires to what you could therefore use in your business or in your house. And those transformers would be affected by major emissions from the sun in high energy wavelengths.
Right. They mentioned that it's too expensive, but then, it's in the business sense, if you have a disruption, it costs even more. So whatever it is, that we'll pay for it. So just be prepared and get more of this transformer.
That's the take-home message, is just be prepared, particularly with climate. I mean, we keep getting the argument of tipping points and somehow runaway climate scenarios, right, and, that things like that. I mean, we have always seen hurricanes. We've always seen floods and droughts, tornadoes. We've seen
earthquakes.
In the past. Earthquakes. Well, we've seen these climate changes that have always happened, and we're always going to see them. So the idea is, if you're living along the coast, you've got to be aware that at some point there's going to be a hurricane or a hurricane remnant that's going to come up and create high winds, high waves, high surf. If you're in the Midwest, that there's going to be severe storms that potentially can produce damaging winds, hail, potentially tornadoes. I mean, these things have happened. They're going to continue to happen. The issue we really need to deal with is making certain that people are able to deal with these kind of events. I mean, small changes that we're talking about in climate change sort of somehow transcends the idea of common sense in some senses, that we become more concerned about a future climate that's more deadly than a climate now that has some things in it that we really need to be paying attention to. So I think there are still lots of things we need to pay attention to in our environment. And certainly I think you started off by saying, we need to be good stewards of the environment. We want to be good stewards of the environment, and certainly do. But we, at the same time, don't want to be chasing after things that really aren't of the fundamental importance and miss things that in everyday life that really are important. One of the things I'm often asked is, are we seeing more floods? Are we seeing more droughts in northern Delaware? And the answer I have to say is yes, we are. And it has to do with humans. But it has nothing to do with climate change. It has everything to do with more people in the landscape, with more asphalt, with more concrete, with more buildings. The problem is When you've got more people, you've got more demand for water. When you've got more asphalt, when you've got more concrete, when you've got more impervious surfaces, when it rains, that water runs off to the streams much faster. So as a result, we sort of recognize that we've changed the land surface. When we run into situations where we have limited availability of water, that little water doesn't quite go as far as it used to because there's more people demanding it. When we have very heavy rainstorms, as we've had in the past, that water is much more efficiently pushed into the rivers and streams, and that creates more flooding. So we didn't recognize that when we were building back in the 70s and 80s, that we had to have retention ponds. Now we recognize the problem, so we're trying to retrofit. So, yeah, we're trying to be good stewards of our environment. There are changes that humans have induced to the climate system and to our local effects. But if we start to believe that the only thing humans do to the environment is carbon dioxide and the only thing we need to fear is climate change, I'm afraid we're going to miss the important things that affect everyday life.
Since we are talking about the context of water and other important things to prepare for, and that climate change is a constant, it's always changing. It's a question of where we're looking. What do you think about desertification?
Well, that's happened in a number of places.
Can you explain desertification?
Sure. Desertification is essentially where you have decreased precipitation and areas, particularly on the margin of deserts, becomes even drier and hence turns into a desert itself. I mean, one of the classic examples of that is the Sahel region of northern Africa. It's on the border of the Sahara Desert. It's an area where rainfall maybe fell 2-3 months out of the year. The people in the area were nomadic herdsmen, so they were moving around, taking their flocks and people around. And one of the things that government does not like are nomads. They don't like people that wander around, particularly when they wander across political borders. So they made them sit still. What happened was they overgrazed the area. They ruined the local vegetation. And as a result, by changing the vegetation, they in fact changed the ability of that wet season to come. It doesn't come for as long, and it doesn't come to be as strong. And as a result, that area has seen a dramatic decrease in precipitation, and that's why we refer to it as desertification. But it's a human modification of the landscape that has in turn affected the climate. It's not a carbon dioxide or a climate change signal that's been driven by SUVs or fossil fuel use or anything like that.
That's an important point. I always wanted to understand that better because a lot of people are psychologically preparing for water wars. We're hearing that there's a huge privatization of water. And conventionally, when we look for water, we're looking into aquifers. And when I interviewed Bill Cox a few years ago about primary water, which is water that comes up through supercooled steam underneath the aquifers, as he talked about water into perpetuity versus only being dependent on aquifers for water, he did say that desertification was causing problems getting waters from aquifers.
Yeah, the problem with increased populations, too, is if you, particularly along the coast, start to overpump the aquifers, you get a lot of saltwater intrusion. And salt essentially destroys the aquifer's ability because then you've got the problem of how do you separate the salt from the water that's coming out of the aquifer, and humans can't drink salt water without becoming dehydrated, so you essentially ruin your aquifers if you overpump them. But we've got, in particularly in the Midwest, we've got a number of aquifer problems where, in a lot of cases, the thought was that the water was endless, and it's not really.
Isn't that what desalinization is about, is taking the salt out of water as a potential water source?
That's usually associated with coastal areas where you've got seawater that has a high salt concentration, and you need to get rid of that. The problem is if you pump an aquifer and it has high salt concentration into it, then you've got an additional expense and problem of how to desalinate the water you're pulling out of the aquifer, and that dramatically decreases the ability of the aquifer to supply water.
Interesting. Okay, so coming back, my last name is Greenhouse, and I'm tired of people talking about how detrimental the greenhouse effect is when I feel like I'm doing a world of good. So I was wondering if you gentlemen could explain to the audiences who are listening to this show, what is the greenhouse effect on a geological level? What does it do? Why are we talking about it? And what is it?
Okay, first of all, the greenhouse effect is largely a misnomer. We say that the greenhouse effect is that the Earth's atmosphere is largely transparent to sunlight and largely opaque or absorbing of heat, so that